Hey guys, I'm going to share with you my hypothesis of why I think there could be large animals living at the bottom of Lake Tahoe. Now, we've already discovered that there is life at the bottom of Lake Tahoe, but this is my theory on why the ecosystem could support something large. I'd like to start with the Bergsman's rule. So, Bergsman's rule states that in colder climates, the same species of animals actually gets larger. So, on the globe here with the equator, the closer you get to the poles, you'll find the same animal actually get larger when you get closer to the poles. For example, we can have white-tailed deer is 125 pounds in Florida. Now, the same species of deer will be 250 to 275 pounds once you get up to Montana. So, that's not only true for mammals, though. We found ants. The same species of ants could actually get larger the closer you get to the poles, closer in a cold climate. That's not only true, we could also find it in birds, reptiles, plants, and even most interestingly, cephalopods. Now, we got to talk about allometry because allometry brings a problem to my theory. Now, allometry is the study of an animal's size compared to its shape. In allometry, we have something called isometric scaling. Isometric scaling is the relationship of its size to its growth during evolutionary periods or even just through its lifespan. So it's ruled by the square cubed rule. Now, that is stating that if an animal increases its length, its surface area is going to be increased fourfold while its mass is increased by 8. And that causes a respiratory problem. The lungs aren't keeping up and it can't keep up to what the animal's new demands are for its 8-fold. On land, there's other issues that come up with that where bone density, muscular structure needs to keep up with that 8-fold increase as well. But in Lake Tahoe, we can mitigate some of those problems. And I have a two-part solution to this. First thing I'd like to go over is the relative viscosity of the water. Lake Tahoe is 1,650 feet deep, and that's going to give us about 740 psi. When water gets under pressure, the viscosity raises. The viscosity also raises depending on the temperature. Increase in viscosity helps support the animal's respiratory system and also how it can move in the water. Now, we also have to talk about Kleiber's law. Kleiber's law states that when an animal's mass increases, it doesn't scale linearly. It's actually scaled to 3/4 power. So essentially, we would just take the animal's metabolism, and that gets multiplied by its mass, 3/4 power. It's a little bit complicated, but let's just run this down. So if we have a cat, and the cat is 100 times the mass of the mouse. Now, even though the cat is 100 times the mass of the mouse, it only takes 32 times the amount of food to keep it and survive and do the same thing that the mouse is doing. In conclusion, these factors would cause life at the bottom of Lake Tahoe to grow in size, not only for defense or predatory factors, but it just seems to be a driving factor in evolution. We see the same thing happen in the ocean when squid become giant squid and colossal squid. And for example, in the ocean too, you'll see the same species of troglobite be massive at the bottom of the ocean at 9,000 meters deep when it's very small up at the top. Now, recently, we've filmed 2 species of fish at the bottom of Lake Tahoe. One of them, I believe, is a morphology of a lake trout. The other one was a long, pale, almost sturgeon-looking thing with a large dorsal fin on it. Now, this brings the species I filmed living at 1,650 feet in Tahoe to 4, including shrimp and jellyfish, besides just the fish. Recently, we've also concluded that the lake trout, the morphology of the lake trout, is using echolocation. We've been hearing the echolocation on the camera when I was using bait, but I didn't get to see what was making it. Now I videotaped a lake trout going right by the camera, and as it goes by, you can hear the rat, those little clicking noises it makes. It makes sense because there's no light down there. So it needs to move around and hunt somehow. So this, in conclusion, is some hypothesis I have that why there could be large things supported by the ecosystem of Lake Tahoe. I think it's worth my time and energy doing, and if not, that's okay. At least if we don't find Tahoe tessie, we'll get to further the information that we know about the native lake species. Also, I have a lot of reports about the same report happening over and over again from different people. I don't think all the people are lying. People tell me, well, I'll leave that up to another video. I'd like to get it on video first before I go on talking about something like cryptids. But thank you for your time, and hopefully this helps people understand why I think there could be a larger life at the bottom of Lake Tahoe.